Okay, let's talk about scientific notation and significant figures for a few minutes. In science, you either encounter really large numbers or really, really small ones. For example, the mass of a single atom of gold would be a decimal followed by 21 zeros and then the number 327 grams. That is such a teeny tiny number as to not make any sense. Same thing at the other end, with 1 gram of hydrogen has 301 and then 21 zeros molecules. Number's so big it doesn't make any sense to anybody. You can't use it with your calculator, you can't do anything with it. So some smart person came up with the idea of scientific notation, where you write the number as a product of a coefficient and an exponent. For example, with 36,000, the coefficient would be 3.6 and the exponent would be 10 to the 4th. So 3.6 times 10 to the 4th. Coefficient written as product with an exponent. You place the decimal behind the first number on the left. Okay? So let's take a look at a couple here. Coefficient's always bigger than 1 but less than 10. So it's from 1.0 to 9.99. Alright? And the exponent tells you how many places you move the decimal, or how many times you're multiplying by 10. So a couple of examples here. For 501, you're going to place the decimal after the 5. It's the first number on the left. It's 5.01 times 10 to the second because you moved it 2 places. For numbers that are smaller than 1, we use negative exponents because you're moving the decimal backwards. So 0.1 would be 1 times 10 to the negative 1. Instead of moving the decimal to the left, I had to move it to the right, because the decimal still has to be behind the first number on the left. For 0.0023, I'm going to put it between the 2 and the 3. I had to move it 3 places, so it's 2.3 times 10 to the negative 3. And to take a number from scientific notation and write it normally, you just work backwards. If I had 2.3 times 10 to the 3, I would grab the decimal and move it to the left 3 places to write it as a normal number. 6.03 times 10 to the 5th. I would take the decimal and move it to the right 5 places, and I get 603,000. Now, significant figures are a little bit different. Let's say I go to the store and buy some bananas, and the scale says between 2.4 and 2.5 pounds. So I'm going to estimate the real weight as about 2.45. I'll split the difference. Now I know the 2 is sure, I know the 4 is sure, but that 5 is a guess. That makes it uncertain. Significant figures are numbers, the number of numbers in a measurement that provide useful information. It tells us all the certain numbers, and it tells us one that's estimated. And basically what they do is to let you know which numbers can't be trusted. Now there's some rules for this, and they're pretty straightforward. First, all the numbers 1 through 9 are significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9. If you see those, they count. They matter. They're important. So if I have 3,452, that has 4 significant figures, or sig figs, because all 4 of those are between 1 and 9. They all count. Zeros in the middle of a number count. Alright? 104 has 3 sig figs. You can kind of think of the 0 as being the middle of an Oreo. It's the filling in an Oreo cookie. It gets sandwiched in between the two. It matters, because why are you eating an Oreo with no filling in it? That's just crazy talk. So it's important. Zeros to the right of a number and after a decimal count. 13.40 has 4 sig figs because that 0 is telling you a precision, the level of precision at which this measurement was taken. Zeros to the left of a number do not count. Those are considered placeholders. So if I've got 0.000032, only the 3 and the 2 count, because the zeros are placeholders. Alright? That only has 2 sig figs. Zeros to a right of a number that doesn't have a decimal don't count. For the same reasons, they're placeholders. So 3,000 only has 1 sig fig. Alright? 3 counts, but the zeros are all placeholders. So really, 1 through 9 count, a 0 in the middle counts, and a 0 after a number after a decimal counts. I know that's a lot, and I know it can be confusing, but you get the hang of it. It's a little bit of practice, trust me.